Welcome back. We learned to aggregate your data over a time-based window. However, we also learned that some of your records might be coming late to your system. Spark gracefully handles these late coming records, and we have seen that in the previous example. Let me quickly refresh the idea. In the earlier example, we simulated a scenario to create a series of 15-minute windows. The first window starts at 10 and ends at 10:15. Similarly, the second window starts at 10:15. But how exactly this happens? Let me explain. You started your Spark streaming application and your first micro batch is triggered. For the first trigger, you have got two records, right? Spark will look at the event time column of the first record. In our case, it is the created time, right? So the created time for the first column says 10:05. Spark knows that we need to aggregate these records over a 15-minute window. So Spark will create the first window according to the event time for the first record. Let's say Spark decided to create the first window as 10 to 10:15. Now the first record becomes the part of the first window. That's all. Done. Spark moves to the next record. The event time of this record is 10:12. This record also fits into the first window. So Spark will place this record also into the first window. That's all. You got only two records for the first trigger. Now it's time to compute the aggregates. So Spark will compute the sums for this window and produce the output. However, the first window is kept in the state store also, right? That's all. You are done with the first micro batch. The background thread will wait for some time and trigger the next micro batch. The next micro batch has got only one record. Look at the event time. What is it? 10:20. Does it fit into the existing window? No. The first window ends at 10:15. So Spark will create a new window from 10:15 to 10:30 and place this record in the second window. Done. Calculate the aggregates, produce the output, and save the second window to the state store. Now you will wait for the third trigger. Let's assume the third trigger is started. You have got two records, right? The first record is 10:40. Do we already have a window for this record? No. My most recent window ends at 10:30. So let's create another window from 10:30 to 10:45. We have another record. Let's look at this one. What is the event time? 10:25. Do we already have a window for this event? Yes. This event should go to the second window, right? So Spark will pull the second window from the state store. Recompute the sum for the second window and update it. That's all. We are done with the second record. Do we have any other record for this micro batch? No. So we are done with this batch as well. Now Spark will produce the output for this micro batch, update the state store, and wait for the next trigger. This is how it keeps going on over micro batches. I hope you got some good sense of how this happens. Now it's time to bring one critical observation to your notice. We saw that the Spark keeps the window state in the state store, right? But why is that needed? Why do we need the older windows? You already know the answer. These windows are needed to handle the late records. Otherwise, we do not need them. The point is straight. All the windowing aggregates are also kept in the state store forever, just like other non-time based aggregates. Spark is not going to clean it unless you set an expiry date for the older window. Cleaning the older state is super critical because the state store is maintained in the executor memory. If you do not clean it, you will run out of memory at some point for sure. So the next question is this: how to set an expiry date for the window state? In Spark terminology, the expiry date for the window is known as a watermark. Setting a watermark is simple, and I'll explain it in a minute. However, deciding your watermark limit is a business requirement. You should ask this question to your business. How long do you want to wait for the late arriving records? Or when is the late record no longer relevant? For example, your stock trading transactions can arrive late. But what is the maximum? 15 minutes, 30 minutes, or 8 hours? We must have some maximum after which the record may not have relevance. In this example, we track this graph daily from 9:15 to 9:30. This graph is not at all relevant the next day because the following day graph is fresh and starts new. So even if you received some late records after the end of the day, you should be ignoring it, right? So looks like 6 hours should be enough to wait for the late records. If it comes after 6 hours, we can safely ignore it. In fact, your business might come back like this. We are expecting this graph to give us 99.99% accuracy. Based on the past trends, 99.99% of our records will arrive in less than 30 minutes of delay. The other 0.01% of records are either lost in the network or arrived too late. So, we do not care for the records that arrive later than 30 minutes. And this is the kind of information you are looking for to set your watermark. Make sense? Now, let's go back to our example and set a 30-minute watermark. Here it is. You can set the watermark calling a with watermark method. This method takes two arguments. The first argument is the event time column. In our case, it is the created time. The second argument is the watermark duration. We want to set a 30-minute watermark. You should also remember two things. You must call with watermark before the group by. And the event time column should be the same which you are going to use for windowing. That's all. Now, Spark knows two things. I can ignore the record if it arrives late by more than 30 minutes. I can clean up the window state if it is older than 30 minutes. Make sense? Let me walk you with some example events. Here is my event chart. I have total of 6 events and the diagram shows when they arrive in the system. Let me run the example with these 6 events and help you understand how watermark works. I am starting Zookeeper and Kafka. Then I'll create the topic and start the producer. Let me send the first event. This event is timed at 10:05. Let me run the application. What do we expect in the output? We have only one event. So I expect one window starting from 10 to 10:15, right? And that's what I see in the output. Let me send the next record. The next event is 10:40. My previous window ends at 10:15. The following window should be created from 10:15 to 10:30. But we do not have any record for 10:15 to 10:30. So the next window remains empty and nothing will show up in the output from 10:15 to 10:30 window. My next record is for 10:40. So Spark will also create the third window and show me the aggregate for 10:30 to 10:45 window. And that's what I got here. Your current micro batch ends here, right? That's what we learned earlier. Each micro batch will process all the records for the current batch, send the output to the given sink, and also send it to the state store. And that's all. Your micro batch ends. However, we defined watermark. Watermark is the basis for state store cleanup, right? So each micro batch will also do some cleanup before it ends. How is that cleanup happens? Let me explain. What is the latest event time up till now? 10:40, right? And what is the watermark duration? 30 minutes, right? So Spark will compute the watermark boundary using the following formula. Your maximum event time is 10:40. Watermark duration is 30 minutes. So you get 10:10. Now all the windows ending before 10:10 should be cleaned from the state store. Do we have any? No. So no cleanup at this stage. Microbatch ends. Now let me send one more record. This record is for 10:20. This 10:20 guy should have come up way before the 10:40 record, right? But nothing to worry. Spark should pull the 10:15 to 10:30 window from the state store and apply it to the older window. Finally, the microbatch ends doing 3 things. Update the state store, clean up the state store, and finally send the output to the sink. Do we have something to clean up? No, right? Why? Because my max event time is still the same. So we do not have any change in the watermark boundary. So no cleanup again. Now let me send one more record. This one is 1048. This record will create a new window from 1045 to 11 and you will see the result. But this new record will change the max event time to 1048, right? What should be the new watermark boundary? 1048 minus 30 minutes equal to 1018, right? So now do we have something to clean up? Yes, we have. The first window, which ends at 1015, can be removed now. Spark will delete this window state from the state store. Hence, any new event generated before 1015 is now outside the scope of this Spark query and it will be ignored. Make sense? You can try sending a record for event time less than 1015 and Spark will ignore it. Similarly, anything more than 1015 will be taken in. The point is straight. Every micro batch will update the watermark boundary. An indicative formula to arrive the watermark boundary is given here. Spark will also clean the state store after committing the sync records and finalize the micro batch. So, next micro batch will start ignoring those late events for which we do not have a state. Make sense? That's all for this video. But let me highlight some key points to remember. Watermark is the key to cleaning your state store. Without watermark, your state store will keep growing and you may end up in memory crisis. If you are setting 30 minutes watermark, then an event arriving within 30 minutes will be considered. And Spark guarantees that the event coming within the watermark will be taken in. It cannot be dropped. All events taking longer than the watermark may or may not be considered. Spark may ignore it or it may take it. Including an event to a window depends on the state store. If the window state is cleaned, Spark will not take the event. If the window state still exists, Spark will consider it. That's all. See you again. Keep learning and keep growing.